Hello everyone, welcome back to my YouTube channel. Today we are going to discuss some problems on Hurwitz polynomial. So I've taken the first problem here. Here the question is check whether the following polynomial is Hurwitz or not. So we'll be solving this problem right now. First of all, I'm writing the question once more. P of s is equal to s cube plus 4s square plus 5s plus 2. The first thing we should do is check whether all terms are present. So first of all, it starts with s cube. S cube is present, then s square is present, then s is present, and s raised to 0 is also present. So all terms are present. First condition satisfied. First condition satisfied. And the next condition is whether all coefficients are positive. I'm considering all the coefficients here. Here s cube has coefficient 1, it is positive. S square has 4 and s has 5 and s raised to 0 has 2 as coefficient. So all the coefficients here are positive. So we have checked our first two criteria. Then we'll move on to check whether the term is either even only or odd. So now I've checked it. There is s cube and s square. It means it's neither completely odd or completely even. It is a mixed polynomial. So what I'm going to do is I'm going to split it into even terms and odd terms. Even terms, I'm splitting it into even terms first. N of s, that is equal to 4s square plus 2. And odd terms is m of s, that will be s cube plus 5s. Okay, we have done that. Now we are gonna do continued fraction expansion. Our next thing is continued fraction, and we are gonna do continuous fraction expansion. First of all, I have to take the numerator. The numerator should have the highest power. So considering the even and odd term, we could see that odd term has the highest power. So I am taking odd as the numerator and even as the denominator. So I am writing s cube plus 5s divided by 4s square plus 2. Okay, now that I have written the fraction, we have to do continued fraction and get the quotients, because the quotients of the continued fraction expansion is the factor which determines whether this polynomial is Hurwitz or not. If the quotients are positive, then the polynomial is Hurwitz. If the quotients are not positive, that is there is some negative values, then the polynomial will not be Hurwitz. So in order to check that, I'm taking the numerator inside. That is s cube plus 5s on the inside and 4s square plus 2 on the outside. Now how can we divide this? It's basically very simple. We just have to make this 4s square equal to the s cube. Just we have to make sure that we matches the first terms on every division. So I am considering 4s square. I have to multiply some value with 4s square to make it s cube. So I'm showing that value as y here just for calculation purposes. So that will give me s cube. That is 4s square into some value will give me s cube. And I'm finding that value, that will be s cube by 4s square, and that will be s by 4. So the quotient will be written here, and that is s by 4. This is the quotient, first quotient. So when I multiply 4s square plus 2 with s by 4, I'll get s cube. So I'll get s cube. Then the next term 5s, and the other term will be 2 into s by 4. That will be basically s by 2. I could write it as s by 2. I could simply write it as s by 2. On solving that, I'll get 9 by 2s. That is 5 minus 1 by 2 will give me 10 minus 1 by 2, that is 9 by 2 into s. S is there. This is s. So s will be there. Then we take the next term. This is the remainder. 9 by 2s is the remainder. Then we take the next term inside. That will be the 4s square by 2. I'm taking 4s square plus 2 into the brackets, that into the division column, and I'm gonna divide it. And how are we going to divide it? We have to make sure the first terms becomes equal. So I have to convert 9 by 2s into some, multiply with some value. I have to get 4s square. So the y will be 4s square by 9s into 2. It will be 8 by 9, 8 by 9s. So I'm doing 8 by 9s here, writing it here. So if I multiply 9 by 2s with 8 by 9s, I'll get 4s square. So 4s square is cancelled, and there is no terms for the value of s raised to 0 in here. There is only s raised to 1. So there won't be any other value. The other value will be 0. So what is the remainder is just 2. Then I'm taking inside the value that we have got here, that is 9 by 2, the remainder from the previous division. I'm taking 9 by 2s inside, and I'm taking 9 by 2s inside, and I'm gonna divide it. How can we divide it? 9 by 2s, how can we find that out? It's basically very simple. So I'm just putting out my previous calculations. So, okay, how to get 9 by 2s? 9 by 2s is our target. We have to multiply something with 2 to get this value. And how to get it? Y has to be 9 by 4s. So I'm multiplying it with 9 by 4s to get 9 by 2s, and the total final remainder will be 0. Now we have done our continued fraction division. Okay, and from this we could see that all the quotients that we have gotten as until now is s by 4, 8 by 9s, and 9 by 4s. All of them are positive. So we could say that since all quotients are positive, hence the polynomial is Hurwitz. So that's all for today. Thank you.